Good morning, everyone. Thanks so much for coming. It's my absolute pleasure to introduce Macklin Hartley to you today. He is a full stack engineer who's been in the industry for nearly 10 years, so a fair bit of experience there. And he speaks about a range of topics, including accessibility, queuing theory, continuous delivery, and feature toggling. And this is his third speaking engagement at DDD. And he's going to be talking to you about how fast is your website really. So please, round of applause for Macklin.
Thank you. Is this working? Yep. All right, so how fast is your website really? That's the question I'm going to ask today. How many people build fast websites? So you all build slow websites. That's probably why you're here, I guess, right? Cool. How do you know if your website's fast, though? I kind of built this slide under the assumption that everyone would put their hands up, but that's okay. How do we even know? That's probably the question that we need to ask at the moment. So, spoiler alert, this is how you know. This is the answer. You need to have user-centric performance metrics. You need to capture those metrics from real devices, and you need to have continuous observability over those metrics. So that's the whole talk, right? No, that's the end of the talk. I'm going to get to that point, but we've got to figure out how to get there, right? Just before I continue on, one thing that this talk is not going to be is how to actually tune for better performance, how to do web performance tuning. That's probably a whole other talk in itself. And actually, there's tons of tips, like Google will give you heaps of tips on how to do that. So we'll separate that out of this talk. We're just going to figure out how to actually measure it first, and then we'll go from there. So let's start by forgetting everything we actually know about web performance monitoring. We'll start from scratch. I like the idea of starting somewhere really naive and then kind of building up from there. So what we're going to do is do the simplest thing that I can probably think of, which is just on that page load event. This is an event that's available to you in the browser. We're just going to track our performance there. So this would be code that you can actually run. And we can see our page took 729 milliseconds to load. So that's nice. Except that kind of falls apart because the moment we look in the Performance Inspector, which is a tool that's available inside Chrome, you can see the red L there, that's your page load event, and you can actually see that stuff's happening on either side of that event. And actually most of it's happening on the wrong side. So that's not telling us anything useful. Basically more of the stuff is happening after that event. So we've got to try and fix that. One thing we could do is we could use the new navigation timing API. So it's a bit more modern than just sort of running a page load event. That is okay, but really that's just giving us a whole lot of numbers that are about as meaningless as the page load event. It's not telling us anything useful. When I get DOM content loaded event end, what does that mean? What does that mean for the user? What does that look like? So a bunch of smart, big brain people have gotten together and actually all realized that we all have the same problem. And they put together the W3C Web Performance Working Group. And this group came together and came up with they coined a term called user-centric performance, or user-centric performance metrics. So what are those? They're centered around a couple of different things. You've got perceived load speed. That's as perceived as in as best as we can represent the load speed perceived by the user. Load responsiveness, which is just how fast that process goes for. Runtime responsiveness, which is after it's loaded, how fast is your website. And then two other things, visual stability and smoothness, which are less about performance, but still really important. And out of that, who's seen these before? These metrics, yep, Web Vitals. A number of metrics with abbreviations that are sometimes hard to remember, that are the key metrics for measuring web performance. Really handy. I'm going to go through all of these really quickly. I know a lot of people put your hands up saying that they've seen these before, so I won't spend too long on them. But we're going to go through what each one of these means just quickly. So time to first byte is the time between when the browser requests the page and when it receives the first byte of information back. And it's kind of just all of the stuff that's happening before your page loads. There's actually quite a lot of it usually. a lot of this happens very, very quickly, so it's almost imperceptible, but a number of things can actually affect how long this process takes. So it's really important to measure that. Google, who I guess are big and heavily involved in the W3C web performance working group, suggests that time to first byte should be under 800 milliseconds. That's a good score, but anything over 1.8 seconds is poor and needs improvement. Next up we have first contentful paint. This is the time from when the page starts loading to when any part of the page is rendered on the screen. So this is going from a white box in your browser to the first time anything appears on the screen. It looks a bit like this. So we can see we captured FCP when that first part of the result comes up on the top. Google's really convenient for testing this stuff because they stream these results back to you. So you slow it down slightly and you can actually capture this. We can see at the top there, FCP's 0.5 seconds. FCP should be anywhere between, should be below 1.8 seconds if you can help it. Anything above 3 seconds is too long and it needs improvement. Next up you have LCP, or largest contentful paint. This is tracking how many seconds it takes for the largest item or the largest most data intensive element above the fold element takes to load. So it looks like this. We can actually see it shifts as this page loads. And we're looking at the largest, we're tracking, oops, we're tracking the largest element on the page at a given time. Let's pick that up. So you can see LCP shifts from the sort of the top of the bottom of the page. Is actually the FCP at the very beginning. But then as as we kind of uncover the largest element as we go, that FCP score changes, and at the end we calculate it at 1.6 seconds. Largest contentful paint should be under 2.5 seconds if you can help it, and anything over 4 seconds is too long. Then you have some other metrics as well, less associated with load times, but still really important. This one's called first input delay. It's the time for the first interaction on the page, the first time your user clicks anything. Google targeted the first time the user clicks anything because quite often while your page is loading, it's quite a data-intensive, CPU-intensive exercise. And if your user clicks anything while that's happening, you are likely to see some sort of delay or incur some sort of less than ideal experience. So they focused on that first input. It looks a little bit like this. Usually it's quite imperceptible. The target scores are very low. So this is a bit more of a contrived example. But you can click that button and then there's an input delay there. And we track that. Like I was saying, quite low target scores there. Usually imperceptible, like 100 milliseconds is quite imperceptible. A good score is 100 milliseconds. Anything over 300 is too long. Next up, this is a fairly new metric called interaction to next paint, and the way to think about this one is it's first input delay, calculated slightly differently, but over the course of the entire interaction with the page. So not just the first interaction, but every interaction on the page, every button you click, every carousel you scroll and stuff like that. Interaction to next paint should be under 200 milliseconds if you can help it. Anything over half a second is too long. There's a slide missing there, but that's all right. Cumulative layout shift is the last one. This one is a little bit different, but I think it's still a really important metric. It's not so much about web performance as much it is about sort of visual stability. The way we can perceive cumulative layout shift. This is why I think it's really important because these are really annoying. They suck, and no user likes this when this happens. This is maybe a less disastrous example, but no, missing a slide there too. Cool. I think there was a famous example where there was a layout shift on a page with a nuclear missile alert test system, and they clicked the wrong one. That's the picture I had, but it's gone. So this is a score between 0 and 1, so it's sort of a calculated score. I think of it more of like a percentage. I don't know if that's actually what it's meant to represent, but anything below 0.1 or 10% is good. Anything over 25% or 0.25 probably needs some work. It's probably got too many of those shifting components that are getting in the way, annoying your users. So a number of these metrics, not all of them, make up what Google call the core web vitals. You can see here, largest contentful paint and first input delay and cumulative layout shift. They make up actually what Google uses to decide where your search engine ranking is. If you're somewhere on a search engine page, typically you can move up that search engine page and result if you have a faster website. So there's actually material benefit here, commercial benefit, in that if you improve the performance of your site, you actually get improved performance sort of in your externalities, for example. I want to talk about largest contentful paint. Why did they choose that one? It's because these metrics they don't have atomicity. So you might have noticed when we went through our examples before, time to first byte, the way it's calculated, usually means you'll get a score that is below first contentful paint and a score that is below your largest contentful paint. Sometimes the first contentful and largest contentful paint will be the same. That's probably a good thing. But what this means is tracking all of these three together, we can actually sort of look at the differences between them and identify which one is having the most impact on your web performance. So for example, if you have a very high number for time to first byte, that's usually an indicator that your user's very far away from where your web page is being served from. You can improve that by bringing them closer together. Whereas if, for example, if your time to first byte is really good, but you've got a kind of larger gap to first contentful paint, sort of in this case here, and then a very large gap to largest contentful paint, we're able to transfer the JavaScript and the HTML onto the page very, very quickly, but it takes a long time to process that, pass the JavaScript and render it. So that's where you'd probably want to set your focus. And setting your focus on stuff like this is really good. Like we have case studies that actually prove that there is commercial benefit to doing this. Vodafone's a really good example. Vodafone's huge, so 8% of sales is an astronomically high number, but 8% more sales when they increase their performance on largest contentful paint. So I think we know how to get user-centric performance metrics now. We know what they are, at least, so we can tick that box. Let's figure out now how to actually capture these metrics. So there's a couple of different ways that we can capture them. You've got ad hoc testing, synthetic monitoring, and then real user monitoring. So I'm going to go into each one of those. Ad hoc testing. Who's used Lighthouse for Google Chrome before? Nice, this side of the room. I'll focus my attention this way then. So Lighthouse for Google Chrome is a tool built into Google Chrome that allows you to test any web page, probably more likely your own, the one that you manage, and it will give you back those Web Vitals scores. You can see them. Well, it's probably kind of small, but they're those numbers in the bottom right corner. It's tracked first contentful paint, largest contentful paint, all of those other metrics. This is really handy. It's obviously a free tool that you can, like, everyone already has. So really good to start using that. But perhaps a better example is this tool here, also provided by Google. This will run Lighthouse on your behalf on a device that is not a desktop computer. So this makes a huge difference because the performance profile of a mobile device, which is what this will run on, it makes a significant difference to the score, and is actually probably more realistic and representative of real-world traffic. Most of your users are going to come from mobile devices. The other interesting thing about this is this will run in a data center in the United States. So if the majority of your customers are there and not here, this is going to be more representative of that too. So this ad hoc testing, this is really great. It's free. Anyone can do this, and I suggest and recommend that people do this. If you've got a website, you should be kind of testing the performance and tracking all of this stuff. There's no setup required. Everyone has Google Chrome. Even if you don't use it, you probably got it. But these are only good for once-off manual tests. It's clicking around testing stuff. We don't have any automation here. And they're also, even though the web performance, the web.dev/measure, that tool runs in a US data center on a mobile device, they still don't really represent real-world traffic. I'll get back to that in a minute. One of our other options is synthetic monitoring. So this is an example of one tool. These are really cool people that build this. They're based in Australia, Calibre. And what we're actually looking at here is a pull request, a comment on a pull request. So the way this tool is set up is every time you create a pull request, you can set it up to, on a deployed version of this change, run a web vitals test. I think it just runs Lighthouse, but on your behalf. It will run on multiple different devices, so it will run on desktops, but multiple different Android and iOS devices for you as well. We'll check that, and you can choose all the locations and stuff like that you run on. So it's a bit more representative of your real-world traffic again. So this is probably a better tool if you want to sort of take the next step. You've got your continuous integration, continuous delivery automation through those pull request checks. So that allows you, if you're doing your regular pull request, to monitor change over time. Unfortunately, this tool's not free. You do have to pay a little bit to use it. And it's still not representative of real-world traffic. So we've got more devices now, but at the end of the day, those devices are still running in data centers. And we're kind of assuming that's how it's going to behave on the real world, but it's still not the real world. Like, I think we can do better. Why do I think this is important? So if we look at browser engines, we might be mistaken into thinking that there's not a whole lot of diversity there. So you've got WebKit-based devices. This is traffic from a website that I currently kind of maintain. So I don't know if this is 100% accurate to like global statistics. But if we look at browser engines, you've got WebKit, so every single iOS device, as well as some Mac OS desktop devices will be running WebKit. I say every single iOS device. If you've got Google Chrome on your iPhone, it's actually WebKit. It's not Google Chrome. And then the rest of it is Blink. So same browser engine as Google Chrome. If you're running Microsoft Edge, you've got that. So not a whole lot of diversity there. Same with form factor. We're down to sort of a two-speed world. You've got desktop devices and mobile devices. You've got a small sliver there for TVs or something, tablets, right? But I think this is probably a naive way to look at it. So you might look at these and go, oh, I really only need to test on an iPhone and maybe one Android device and a Windows desktop, maybe. That should be enough. I don't think that's good enough. Let's have a look at, this is a graph showing the single core scores of devices, a wide range of devices, mobile devices. It goes up to 2020, so I think there's been some shifts as well. But the really interesting thing this is telling us is there's a huge, like, massive difference in performance between top-end devices and low-end devices. And the problem here is the majority of your users aren't running those top-end devices. This is like if you're, who here has an iPhone and is running tests on it regularly? Cool, one person. This one person, I can tell you that maybe what you're doing is not representative of what the majority of your users are experiencing. So to put it another way, and this is obviously with old data, we've got a new iPhone that's just come out, so this is going to change again. The difference in performance between those two devices is so significant that we've got a term that's been coined for this. It's called the performance inequality gap. Yeah, that's a big difference there. That was actually coined by this guy. He does some really interesting talks on that. I've got some links at the end to the talks that this guy's done before. He has a really interesting part on his talk where he's running these performance benchmarks on these devices, and just to sort of add to this as well, he's got a Nexus 5X. He's tested it once, and then he puts it on top of a block of ice, and that device now performs 15% faster. So that's really interesting. This now means that the environment in which you run your website and these benchmarks are working in also changes performance. So that score that you had before, that could be 15% higher or 15% lower. And this isn't just sort of like no one's actually running their devices on a block of ice, but if you're outside on a 40-degree day in Perth, you could actually have users that are experiencing your site with 15% less performance. So this is a real thing that does come up when we're talking about real-world sort of metrics and real-world tracking. Another thing that's really important is, I think a lot of us work under the assumption that networks are widely a lot faster and a lot more capable than they've ever been. 4G itself is very widely available. That's great. That's a bit of a miracle, actually, because it's pulling us forward. We have a significant reduction in the use of like our sort of 4-second budget. 4 seconds is for LCP. We've made huge strides, and all sites are generally a lot better performing for this. But that only works under the assumption that 4G networks are evenly distributed, which they're not. If we look at the sort of variance within WA in 4G network speeds, at the low end you've got about 18 megabytes per second, and at the high end you're talking almost 10 times higher than that. Same goes for latency. Latency can differ very significantly, particularly on 4G networks. 4G, by the way, networks, the majority of devices are browsing on as well. So that is where you're going to see the majority of your devices, and the majority of your users with their devices are going to be experiencing this sort of variance in performance. So hopefully that tells you that we probably need to actually start monitoring on real devices so that we can account for environmental factors, different 4G networks and different temperatures, as it turns out, as well as different CPU performance on devices. So what is real user monitoring? Real user monitoring is capturing performance metrics directly from devices so that we can observe differences in functionality, reliability, and responsiveness. So an example of how to do real user monitoring might be the Chrome user experience report. So I think we all know that Chrome, while you're browsing the internet, is doing all sorts of tracking. Some of it's good, some of it's not so good. This is maybe one of the gooder ones, I'd say. Every single website you visit, Google is sending, it's anonymizing and then sending Web Vitals metrics to itself. It collates all of those metrics and makes this data set completely free and available to you. So you can pull down this data set now for a site that you manage, and you can see how it's performing on real-world devices across the internet. The Chrome User Experience Report is great because it's free. You can see, I can go and see the Chrome User Experience Report for google.com or facebook.com. It's widely available. It does do real user monitoring, so cool, ticks that box. The one downside is that it doesn't give you these metrics in real time, so you can pull this report once a month. That's a bit unfortunate because if we made a change and we were worried about the performance, that feedback loop is too long. What happens there is you might make a sort of a performance regression. You incur the cost of that performance regression for an entire month before knowing that you've done that, and then you have to go and try and figure out what caused that a month later, so that's not ideal. The other thing is this only profiles Google Chrome devices, so you don't get realistic real user monitoring for iOS devices based on WebKit. And actually not even all Chrome devices, just Google Chrome, so not like Blink, Microsoft Edge or anything like that. They're not sending data to Google for you. So it's not representing everyone. Here's another tool. This kind of fixes with the Google Chrome User Experience Report, there's a couple of hoops you have to jump through. You have to get a Google account and then use this Data Studio thing, set it up. This kind of just makes this a whole lot easier. You don't have to create an account or anything like that. You can just plug in a site right now. Anyone here could just do this in about 2 seconds. It's made by the Calibre people too. And I've been told to put the sponsor slide either at the beginning or the end, so the DDD people are probably panicking now because I'm about halfway through and I've got the slide here, like, is he finished? No, I've decided to do something probably that might get me a little bit in trouble, but I'm going to do a sponsor leaderboard, so I'm going to go through all of the sponsors to tell you how fast your sites are going to perform. Yeah, all right. So just some ground rules when we start. This is how I'm going to run the tool. I'm going to run it across the whole domain. You tend to get better results. It's more representative of everything that's going on, as well as there are some sites that aren't going to have enough traffic, so you need, I think, at least 1,000 visits on Google Chrome per month, so some of them are going to get missed out there. And the other thing is I'm going to order this dashboard in descending order from the LCP metric, because I think that one's most important. We touched on that before, the case study for Vodafone. That tends to be the one that's tied to commercial benefit. So we're going to go that one. So a couple of people got off the hook, didn't get enough traffic, so good for them. Maybe next year. And this one's a little bit embarrassing. So I work for one of these companies. It's the one on number 20 there. So what happened there? I can explain that, and I think I will. That website there is more so a recruitment tool than it is the website that we derive commercial benefit from. So that's why that's like that. Also, I have nothing to do with that one, so that's probably why it's like that. Some other interesting scores here. We have the lowest score, obviously, for FCP and LCP on this dashboard. Really interesting, though, that for Insight, not sure what happened, the FCP is larger than the LCP, so a bit confusing. I don't think that's actually possible. Maybe that's a dud result. Scrub that off. Now we're last. Great. There's also a 0 score for cumulative layout shift here, so good on Family Zone for doing that. Let's move up the board here. Some more interesting results. What have we got? Planet Testing has a interesting score for cumulative layout shift of 1. I'm not sure what to make of that. That's a bit odd to me. Maybe that's just a bad result as well. We've got Bunnings along the middle there. I should say that when I'm identifying this stuff, obviously this could be taken or construed as a bit of a roast, but I also see this as an opportunity for improvement. Until you see something like this, anyone work for Bunnings? Cool, at the back. This is a really, there's probably something really simple that's causing something like this, especially if it's right across the board. So there might be opportunity for improvement here. Have a quick look at it. It might sort of highlight something that you hadn't seen before. We've also got the best score for first input delay from Telstra Purple here, so good for them. And I've got an interesting result here as well. So Bank West, best score for time to first byte, awesome. Better than AWS. So globally redundant, massive network, probably the largest single network in history ever made. And Bankwest, dingy little bank from Perth, better time to first byte. So whatever the Bankwest people are doing is probably pretty good. Yeah. So actually, that is a good point. Data center and customers, majority in Perth. So that's probably where that's coming from. Obviously, AWS much more distributed. So. And here's the final result. So who saw that one coming? DD Perth, number 2. There's obviously some really smart people putting that one together. The only green across the board score was Versent, so good job to them. And then number 1 score is GitHub. Anyone have any theories about why GitHub's number 1, aside from massive investment in web performance? Reese? Yep. So for anyone who didn't hear, yeah, Reese's mum doesn't use GitHub, as it turns out. I kind of assumed she did, but also, yeah, desktop devices, majority of people with like high-powered devices, largely text-based, pretty much all text-based as well. That tends to help. So largest contentful paint. If you've got images on the page, you'll be impacted by that. So some of these scores as well should be mentioned that. Take them with a bit of a grain of salt. It's not like GitHub is doing something particularly special. Sometimes it's actually more the user base themselves. But again, yeah, plenty of opportunity for improvement here as well, particularly if you've got some of the results on this sort of part of the board as well. There might be something really simple. I'm not going to talk about that in this talk though. That's probably the next one. See you next year. All right, so we figured out how to capture metrics from end user devices. There's a number of really easy ways to do it. But we're still missing continuous observability. So we've got our Chrome user experience report. We can get this data, but we can get it once a month. So that's not really good enough. We need to be able to see this data at real time. Here's a bit of our progress as we go here. So you can see we're improving along the way there, but we don't currently have that solution that gives us all 3. We haven't quite worked that out yet. So if we can't find an off-the-shelf tool, why don't we just ask ourselves, is it really that hard to build yourself an analytics service? Can we build it ourselves? We might as well have a try. We've been through all the tools. Nothing seems to be quite hitting the mark on all 3. Actually turns out it's really easy. So You can grab this library. This is the Web Vitals library. It's the same library that I guess they built into Google Chrome. It can give you the same scores, but you can run JavaScript. You can pull that down, and it looks a little bit like this. You can just import a bunch of functions. You can add callbacks to them. That send to analytics function, I'll get to that in a sec, but we can also, while we're here, if we're going to send something to our little analytics service, we can capture some other stuff as well. So JavaScript errors, content security policy violations, we can send all of that stuff down there. That send to analytics function looks like this. It maybe looks a little, I've got prettier run over this, so it maybe looks a little bit hard to read. It just sends a request down to a server so we can start reporting these metrics. That navigator.send beacon way is a better way to send metrics like this because it can finish the request somewhat after your page unloads, goes to the next page. So if your user clicks on something and you really want to quickly report a metric there or an error or something like that, that's more likely to capture it. But let's fall back to fetch just in case. And I'm doing a bit of code golf here, so I've tried to compress it all into one page, but this is the entire server. This is the whole thing. So really, 24 lines of code is all it took. We can see here that we're importing this prom client library, which is the Prometheus library. We'll get to that in a minute. We can set up our metrics like this. We're using summary metrics, so that allows us to observe time distributions. And then that's the server. It's just an Express web server. Depending on which metric we get back, we'll just observe each one of those. So then moving on from there, we've got our analytics server in the middle. And then because it's just a really simple web server, we don't have, it's not sort of paired with a database. There's no persistence or anything like that. We can keep our metrics in memory. The way of doing this with Prometheus is it's pull-based. So that's polling on a continuous basis our analytics service for the latest version of the metrics, keeping track of that. And then we've got Grafana slapped on top of that because Grafana has really nice, pretty graphs, which we'll show in a minute. But this is dead simple. And because we've rolled our own analytics service, I'm not going to tell you all to use Prometheus and Grafana, that's what I use, but there's nothing stopping you from hooking this up to Honeycomb or sending this data to New Relic if you wanted to. There's about 1 million different options for this, and you can send it wherever you want. And because you've written your own code for this, that is completely up to you. So here's another example where we might want to store our metrics for more long-term use. So you've got Amazon, Kinesis, Firehose, and S3, and then you can use Snowflake to run queries over that data. Dead simple. Also, there's probably 15,000 different ways to do this as well. This is just one example. And we don't do this yet, but yeah, I can see there being value in sort of having long-term trends for those metrics rather than something that lives in memory. So as soon as those containers are dead, then you have to start again. And this is what we end up with. So this is Grafana, quick video from Grafana. We're tracking all of those metrics. We've got an instantaneous score, so that's really helpful for if we've made a quick change, we can just look at that and see if that number's gone up. We can observe trends over time. I've got heat maps there, so I've got a histogram type metric as well, and that allows us to sort of see that distribution over time, and we can kind of observe any of those trends there, so that's really useful. I really like the one in the bottom right as well. Those are tied to the actual performance scores that I showed you before, so green is in that good space, and then anything above that is red. We can see how often we're going into that red there, so that's really, really helpful too. If you remember, we also sent some other stuff to our analytics service, so now that we've got this server, we can kind of start reporting on everything that's going on as well. So I've got some geolocation stuff in there, which devices people are using. Because we have our own analytics server, it's really easy to just keep adding more to it. This is where I got the device data from as well, from the previous slides. So yeah, to recap, best way to do web performance monitoring is to do 3 things. You need user-centric performance metrics. You need to capture those performance metrics from real-world devices. And you need to be able to continuously observe those. So we need to be able to see the advantage of being able to continuously observe is we can capture a quick regression. We can have a PR that gets merged, everything starts running. Oh, look, something's gone wrong. The performance profile has changed in the wrong way. We can roll that back very quickly. Yeah, that's all of it. That's the three goals. We did it. Thanks, everyone. That's me. If you want to like attack me on Twitter for roasting the place where you work, so that's how you do that. If you want to do that. I've also got all the resources here. You can find my slides using any of those links there. I'll share them out. So all the resources, everything I talked about is there. Here's how to learn about all of those metrics as well, more than just the 10 seconds I gave them on stage. Here's some really useful tools. So all the tools I covered versus some other stuff as well. Has anyone got any questions? Reese, making me nervous, man.
No, I just wanted to get your opinion. So there was, Google had those kind of green to red, not so good, good. I was kind of surprised that the numbers nowadays are still quite high. I think you said 1.8 seconds for first contentful paint. Like, I shut it. 1.8 seconds, oh my God, what are we doing? Like, you know, what are your feelings on that? Am I being ridiculous, or is what's good for Macklin? What do you think is good? What are you aiming for?
I think you might be surprised. Like if we go back to, I'm not going to go back to the leaderboards, you guys don't need to see that again, but if you go back to the leaderboards, quite a lot of first contentful paint, I don't think anyone got less than a second. Less than a second sounds really good, that sounds like what you'd want, but it is actually pretty hard to get to that score. And I think Google has set it in such a way that I think it accounts for that variability. So not everyone has a device that's going to ensure that we can get it in 1.8 seconds. The majority of people have devices that are significantly slower than the device you and I probably use. It's accounting for that. It's accounting for people in jurisdictions like geolocations like rural Australia or parts of India and stuff like that, where they are going to not actually be able to attain that level of performance as well.
One of the 4G providers was 10 times faster than the others. Do you know who that was? So I can switch my mobile plan.
So the question was one of the 4G providers was really fast. That was actually based on location. So and it wasn't Perth either. So that slide was across WA. You actually tend to find you get better performance in some rural but not very rural towns. So I think that might have been something like Kalbarri. They've got a tower there. It serves comparatively less people than it does in Perth. So some Perth suburbs mostly sort of sit around the middle there, and then very rural places will have those lower scores.
Awesome talk, man. I love the sponsor comparison. We also, at my company, were using the Google library to send the analytics to, in our case, New Relic. And New Relic also monitor that through their own mechanism. And we found that the numbers were different. And I just wondered if you'd come across different values for the Core Web Vitals with different tooling.
That's really interesting. Yeah, they vary a lot. And like if you just run two Google Lighthouse scores back to back, you're not going to get the same results as well. But yeah, even if we're kind of looking at exactly the same data, I'm not sure the difference there. The one thing I could probably say is maybe that Web Vitals library, it has to run sort of in JavaScript space, JavaScript runtime, whereas the one that's built into Google Chrome, as much as they try and keep that the same, maybe they can kind of detect different things in the browser and they come up with different scores. I'd imagine they keep it as close as they possibly can. But yeah, that's some sort of variability in there. How much different was it out for you?
It was mostly around the CLS scores. So like the New Relic one was very positive, but the Google one was it felt more realistic. So we sort of trusted the Google JavaScript library more than New Relic's at the time.
Yeah, okay, that's interesting. I don't know how New Relic can put that together as well. I imagine there's a guide for how to put it together. Maybe I know that that Web Vitals library is largely something that supports Chrome more than other browsers. Maybe New Relic went and rewrote it themselves and figured out how to get it to work in WebKit and Firefox. I can't speculate on that, but there could actually be different codes sort of detecting that.
Thank you so much, Macklin. If everyone could just give him another round of applause for that amazing talk.